Hello everyone, this is a lesson for absolute value functions. This matches lesson 1.6 in your textbook, and our learning targets for this lesson would be to describe the characteristics of absolute value functions. There are a lot of new characteristics we will be talking about today, and then we are going to get into graphing absolute value, and we're going to heavily depend upon our translations that we've learned earlier in the chapter. So I'm going to focus on the characteristics first. So I'm going to just scoot down to this section, and we will come back to vertex form and graphing later. So the first thing I want to talk about is positive and negative intervals. And if you have a couple of highlighters, this would be a really good time to grab them. So positive means that it is above the x-axis. And when I mean positive, I mean your y values are positive. But we're going to identify it using the x values. It can be a little bit confusing, but once you get used to it, it's not too bad, but you do need to practice. So once again, all of your positive values are going to be above the x-axis. All of your negative values are below the x-axis. Now you need to understand that anything that actually fits exactly on the x-axis is neither positive or negative. So they're kind of neutral, and they will not be equal to a boundary if you are writing an interval. So let's go ahead and do some positive and negative examples. If you flip your notes over on the back, you can see a couple of boxes for positive and negative. So I'm going to choose a highlighter color for a positive, and I'm going to choose another highlighter for negative. I'm going to let that one be blue. I'm going to go over here, and if you notice, this is the same graph. It has been repeated. I wanted you to see all of the different intervals using the same graph. So using my positive highlighter, I'm going to graph any part of the graph that is above the x-axis. So starting on the leftmost side, all of this is above the x-axis, and I'm going to stop when it's at the x-axis. Now you see, when it goes below the x-axis, it is now negative. So all of this is negative, and then it hits the x-axis, and above it, it becomes positive again. So when I'm talking about specifically a positive interval, I have two parts. So this one would be part 1, and then this one would be part 2. So if I look at just this first part over here, this would be negative infinity because, with it being an absolute value, it's going to continue in that direction. So the leftmost positive region is negative infinity, and you guys know that we're going to put parentheses around that. So we're going to track it up until where it is not positive anymore. So it is not positive anymore as soon as it hits the x-axis. So that's going to be at 1. And we do not include that in the positive part because it's not positive on the exact axis. So you have to use parentheses. So when does it start being positive again? As soon as that hits 3, you have another boundary. So right at 3, we're going to put parentheses here because it's exactly on the axis at 3. We don't include that with positivity. And then it's going to continue to move to the right forever, and it's going to never stop. So it's going to go all the way to positive infinity. So if I've got two parts, this is the first time that we're going to use that symbol that I showed you in interval notation. We're going to use that union symbol right there. It just means first part or the second part, it is positive. Okay, I'm going to go ahead and highlight the exact same parts. This is my positive parts, and this is the negative. Now, since this is the negative section, I'm going to go ahead and take a little note. What is the least or the leftmost point of the negative? It is at 1. Now, notice I'm using the domain to describe positive and negative values. So that would be at 1, but not including. And then it continues to be negative up until the rightmost point at 3, but it doesn't include. One part, easy peasy. All right, next up, we're going to flip it back over to the front part, and we're going to talk about increasing and decreasing. So there's a little note I would like you to add. We're going to read our graphs from left to right. Okay, so the only time you don't read your graph from left to right is if you're looking at the range. That's of course minimum to maximum and end behavior, and we haven't talked about that one yet. Okay, so starting over here on the left-hand side, we're going to start reading this one, and I want you to notice that you're kind of heading in a downward motion. That's decreasing. Well, we're looking for increasing, so I'm going to use my yellow highlighter. And as soon as this starts to increase, I'm going to highlight. So at the origin, it's kind of like, it's changing its mind. So it's kind of neutral right there at that vertex. So it starts at 0, but it doesn't include 0. So if I wanted to write my interval notation, I would say it starts at 0, and then it continues to go to positive infinity. And that's the notation for increasing. Now this one has been reflected. But do you see how it actually starts at the left? It is increasing, and then it stops, and then it decides to decrease at that point. So how do I write that using interval notation? It starts at negative infinity, and then it decides to stop at 0. So 0 is where it's changing its mind. It's neutral. That's why we are using parentheses. Let's scoot it over here to decreasing. So as I am reading this left to right, see how I have this decreasing downward motion. I'm going to use blue for decreasing. So this part of the graph is decreasing, and then over here it's increasing, and then it changes its mind and it decreases. So as you read your graph from left to right, you can see that this is decreasing. How do we write this using interval notation? Just like we did on the last one. This one starts at negative infinity, stops at 0. This one starts at 0 and keeps going forever, so it'll go all the way to positive infinity. All right, let's try a couple of increasing and decreasing on the back of your notes. Okay, so instead of talking about positive versus negative, we are looking at increasing and decreasing. It doesn't matter if it's above the x or below the x at this point. So reading the graph from left to right, we are decreasing, and then right here at this point, it decides to change its mind to increase. Okay, so this is increasing. Where did it start increasing? You've got to look at your domain. It looks like it started increasing at 2. Does it ever stop? No, it doesn't. It keeps going to infinity. The question you have to ask yourself, though, is it actually increasing at 2? No, because it's the vertex, it's changing its mind between the two directions, it's neutral. You have to use parentheses. And then you can't be equal to infinity, so once again, parentheses again. Over here, we're going to do decreasing. I'm going to use blue for decreasing. I start out decreasing and I stop at that same exact place where it started to increase. So this time I'm going to start with negative infinity, and it's going to go all the way up to where it stopped decreasing at 2, but don't include 2 in your answer. So that's pretty much it for the interval notation section of describing your characteristics. Now what we're going to do is talk about something called end behavior. And end behavior is basically your extreme behavior of your graph. What are the far right and far left behaviors of your graph? And the easiest way to describe that is to look at the arrows. So I've got two graphs right here. One shows a positive end behavior, and then the other one is showing a negative end behavior. If you were going to draw arrows on your absolute value graphs, go ahead and do that. And one thing I've started doing with my students is asking them to focus only on the arrows. We don't really care about reading left to right. We're not looking at maximum minimums. None of that matters. Circle your arrows, okay? So your arrows are going in different directions. They're going up, they're going down, left and right, kind of depending on the graph. So before I get too far into this, what I need you to do is I need you to get kind of like a scrap sheet of paper, and we're going to talk about all of these different directions, okay? So you know that you have a coordinate plane, and this is your x-axis, and this is your y-axis. So if I was going to ask you which axis talks about left to right, wouldn't that be your x-axis? So if I said x-axis, you're going to think left to right. You're going to think domain, left to right. If I wanted you to think about up and down, so up and down would indicate range, which would be your y-axis, okay? So from now on, I want you to think your x is left or right, and then I want you to think about y being up or down. So mathematically, how am I going to decide which direction that we're talking about? So if you go to the right on your x-axis, isn't that positive infinity? And if you go left, it would be negative infinity. We've been talking about that a lot. If you go really far up, it'll be positive infinity, and really far down would be negative infinity. So these are all directions in your end behavior notation. So your end behavior notation looks something like this. It's got a little arrow in here, and I know that's misleading. I'm sorry. It looks like it means to the right, but it actually means approaches. So what happens is in your end behavior, you have either an X or a Y in this spot. So if I tell you X approaches something, you know X is going to approach either the left or to the right. If I change that and I say Y approaches, you're going to think Y is going to either approach up or down. Okay? Easy enough. And then what we do is we replace this side with an infinity. It's going to be either positive or negative infinity. So if I put positive infinity, you know that Y is going to go up. If I put a negative infinity here, that means that Y will be going down. So let's do a little quiz. I want you to tell me what direction each one of these means. So if I write X approaches negative infinity, that's got to be what, left or right? And then that's going to be to the left. So this actually means to the left. If I remove this and put positive infinity, it's no longer going to the left, it's going to the right. If I change this letter and I change that to Y, it is no longer to the right, it is now going up. And then if I change this to negative infinity, it is now down. So now you understand how to read this end behavior notation. So let's look at it. So looking at this graph, we have two arrows. Notice how I have one on the left. This is left and this is right. But not only are my arrows going left and right, they're also going up. That is your end behavior. So your graphs are all going to travel left and right, except for you need to decide, are they going to go up or are they going to go down? And if it's an absolute value, it's either both up or both down. So if you look at this notation here, X approaches negative infinity. So what direction is that? That's to the left. So as you can see here, as it's going left, it's going up. Now look at what it says here. Y approaches positive infinity. That's exactly what it's saying. So it's not that you have to come up with this notation on your own. You just need to be able to see this notation and understand it. Not only do you need to understand, you do have to understand that it is describing the far extreme value of your graphs. So look at your arrows. That's all that you need to be looking at when you're considering your end behavior in your polynomials. So if you just look at this one right here, this one means we're going to go to the right. And as your arrow goes to the right, it also goes up. That's what you need. So same exact thing over here. It's going to start with left. This is left and down. So the only thing that's changed is that we have that negative infinity right here. And then it is right and down. Okay, let's do the end behavior on the back of your notes. Okay, so we don't have any arrows, but we know where they belong. So I'm going to put my arrows in here and I'm going to circle them. And I'm going to write down in words what's going on. So my right arrow is going up. And my left arrow is also going up. So if you had multiple choice in front of you, you could very easily kind of select which one is which, but we don't. So I'm going to show you how to come up with it on your own. So let's go ahead and start with the one for the right. So X is left and right. So to the right would be positive infinity. To the left would be negative infinity. So this is right and left. And then I'm going to change colors, and then we're going to describe the up and the down motion here. I don't think I mentioned it, but I'm going to mention it now. Y can also be f of x, because remember, they're interchangeable. Okay, so y has to be going up, so I have to use positive infinity. Congratulations, you just described the end behavior. So just let me know if you have any questions, especially on the end behavior. Alrighty, so we are finished with describing the characteristics of the graph. Now we're going to actually graph. We have vertex form right here. I want you to write it down right here above our graph. This is the parent graph here. It is y equals absolute value of x. Notice how we don't have any translations, any reflections, or stretches or shrinks. And what we're going to do is we're going to notice that A is going to reflect if it's negative, or it could possibly stretch or shrink depending on if it's greater than 1 or if it's between 0 and 1. Then we've got the x minus h. So that h, what that's going to do is it's going to move the whole graph left or right. And then if you add k, that's going to move it up or down. Just kind of depends on if you're doing positive or negative numbers. If you were going to use h and k solely to find the vertex, what you would do is you would change the sign of the h. So if it's minus 3, then it would be positive 3 in your vertex, and then k would be the same exact thing. It's because if you are adding or subtracting to your x, it's going to move it the opposite direction that you expect it to. And I'm going to make a quick mention about your axis of symmetry. Since you have a V-graph, you have an axis of symmetry that goes right down straight through the middle of your vertex, which means your axis of symmetry would be x is equal to whatever your h value is. All right, let's go ahead and move past and scoot to right here. So what we're going to do here is we are going to graph this function. But the first thing I want you to do is kind of do like a ghost parent function. So I'm going to put like the tiniest of tiny dots here. So my parent function would start at 0, 0, and you go up 1, over 1, up 1, over 1. So little bitty dots, please do not connect. But do you see the pattern going on here? And then the other side, up and to the left, up and to the left. So it kind of gives us our shape of our parent graph. So what we're going to do is we're going to write vertex form under the function, and that's going to help us find the values of h and k. And if there is one for a, and there always is, we'll talk about that in a second. Okay, if you have 3 highlighter colors, go for it. If not, it's okay. All right, A. You don't see anything in front of that. That is 1. So if A is equal to 1, that means there is no reflection, there is no stretch, and there is no shrink. If there is, you would have to apply that first, then you would need to translate. Okay, I do have something here. Change your sign. H is going to be positive 2, and K is going to be negative 1. So if you look at this, see how you have x minus 2? That's going to shift your graph right 2 places. So it's going to be at positive 2 now. And then the minus 1 is going to shift it down 1. So it kind of makes sense that your vertex is going to be at positive 2, negative 1. So I'm going to go over here. I'm going to graph 2, negative 1. So over 2, negative 1. See how, I'm going to highlight this right here. See how that's moved 1, 2 to the right and down 1. Since you don't have any stretches or if you don't have any stretches or shrinks or reflections, you can go ahead and use that same pattern as before and connect your dots. Now, if you don't want to use your transformations, you can use a table of values and plug each x into your y. It just takes a really long time to do it. It's a lot easier to use your transformations. And we've answered this question. It says, what is h and k? So we wrote them down right here. Describe the transformations we did, but we just didn't write them down. So we went to the left, and we call that a translation. Left. We did not go left. We went right. Translate right 2. And then we also translated down 1. And that's it. All right, let's flip it over on the back and let's do the more challenging problems. So for those of you that like a challenge, you may enjoy this. I do like a really good challenge myself. So what it wants us to do is to graph each absolute value function. So that's kind of clue number 1. I know my graph's going to be in a V shape, but it has to have these given characteristics. So this one says I have a range. I'm going to use purple for range. And it's going to go from negative infinity up to 1. Remember, that's minimum and maximum. So negative infinity is all the way down here, and I'm going to go all the way up to positive 1. So my graph is going to exist only in this section. It cannot go above positive 1. All right, so that probably means that it's going to be, this kind of absolute value graph. It has been reflected. Okay, it also says it's symmetric. That's that dotted line that goes right down through the middle of your graph, where x is negative 2. Well, x is negative 2 is right here. So I'm going to put a line of symmetry here. So it should reflect over this line. And then it tells me that I have a graph of, I have a y-intercept of negative 5. So 1, 2, 3, 4, 5 right here. Now, if I know that's a line of symmetry, if I'm 2 away, I'm going to be 2 away on the left. Okay. So the highest point I can go is at positive 1. So that means that my vertex has to be right here. So I'm going to go ahead. I think I've got enough information to graph. And that is the correct answer. Like I said, these are pretty challenging problems. Okay, last challenge problem. If you want to pause that video, try to give this one a go on your own. That would be great. If not, let's just keep listening. All right, so this one says it's positive over the intervals. Now, remember, positive means that it's going to be above the x-axis. So where is it going to be above the x-axis? So between negative infinity and 0. So I'm going to have a graph somewhere up here. I'm going to very lightly kind of sketch something here. I'm going to erase that, okay? Because that's not exactly where it's going to be. That's just a guess. And then it's positive from 1, 2, 3, 4 here. So I'm thinking, so it ends here and it starts again here. So it's going to look something like that, okay? Let's see what else they give me. It says it's negative over the interval 0, 4. Well, that makes sense because it's going to be negative here. So it's going to be something like that, but I don't know how far down that's going to go. Well, it tells me right here. So if I've got a minimum value of negative 4, then I know that I'm going to 1, 2, 3, 4. That's the lowest it can go right here. Now, I want you to think about it. It's a symmetric graph. So what's smack in the middle of these two right here? Positive 2. So my vertex, my minimum value has to be here. I know that it starts being positive here and it stops here. So I think what I'm going to do is I'm just going to connect like that right there. And that's it. That's how you do these problems. It's a lot of content, so thank you for staying with this whole video. Please let me know if you've got any questions, and good luck.